Good day, everyone. Today we are talking about section 6.3, solving equations in factored form. Our learning targets for today: I can use the zero product property to solve equations in factored form. I can factor out a greatest common factor from a polynomial. I can solve an equation by factoring. I can use the vertical motion model to solve word problems. All right, so the zero product property, pretty straightforward. It says if A times B equals 0, then A equals 0 or B equals 0. One of those unique properties about 0, the only way you can multiply and get a product of 0 is if one of the numbers are 0. There is not a possible way to multiply and get an answer of 0 if one of the two numbers are not 0. This is something that is going to come up multiple times in this chapter. The terms roots, zeros, solutions, and intercepts are all interchangeable. So when we say find the roots of a polynomial, or the zeros or the solutions or the intercepts, we mean the same thing. And so this first set of directions is going to say to solve, use the zero product property to solve the equation. What we are doing is you are setting each part. So like this first part here would represent A, and this part here would represent B. And so if A times B equals 0, either A equals 0, so x minus 4 equals 0, or x plus 2 equals 0. It could be both, but at least one of them has to be 0. So on the left side here, we're going to add 4 and we get x equals 4. We're going to subtract 2 on the right and get negative 2. Remember, when I am writing my final answer, I am going to write them as a list. So negative 2, comma 4. And that would be my final answer. Now, a way you can do this, if you wanted to, is you could go equals 0, draw yourself a little bar between the two problems, and go, I'm solving the two separate problems this way. So again, I'm going to add 5, and I get 5 equals x. Here I'm going to add 1 and get x equals 1. Again, final answer listed from smallest to largest. That is basically what the zero product property is. Now, we will use this when we go to solve equations. If it's just 2x equals 0, there's just one part, so you're going to divide both sides by 2 and you just get x equals 0. One answer. And if there are multiple parts, that means you're going to have multiple answers. So like this top one here will have 2 answers. The one on the right here will have 2 answers. This bottom left problem, this R problem, will have 3 because there are 3 parts. The zero product property still applies. You set all 3 parts equal to 0 and solve. So what I'd like you to do is pause the video and try each of these problems. All right, so this top one, the Q problem, this top middle here, you should get negative 1/4. Again, I need to subtract the 1 and then divide by 4. And then again, Q equals 3, so negative 1/4 and 3. The W problem, if it's just a plain variable out front here, you'll see this in the W problem and the Y problem and the R problem. If it's just a single variable that's equal to 0, it just equals to 0. We solve, we get negative 8, so negative 8 and 0. The bottom bottom row, the R problem, again, 3 parts, 3 answers. So you get negative 2/3. Again, you have to subtract the 2 and then divide by 3. So you get negative 2/3, 0 and 5. The T problem, you get negative 3 and 2. The Y problem, negative 7/8 and 0. All right, rule number 1 in factoring. Again, it's bold, bigger for a reason. This is always the first rule in factoring. Factor out the greatest common factor. We call this the GCF. The greatest common factor, let's break it down. It is the largest value common to all terms. So when we are looking for the GCF, you're looking for A. These are the questions you're going to ask yourself. The first question, does the smaller value go into the larger value? Because if it does, that's automatically your greatest common factor. If not, you go, what is the largest number that does go into these? If you struggle with this, we will talk about how to use your calculator to do this in class. So does 16 go into 40? No. But we know that they're even, so we know that 2 works, but is there a bigger number than 2? So if 2 works, we try 4. 4 goes into both of them. If 4 works, we try 8. So we keep doubling it. 8 goes into 16, 8 goes into 40. And we already know that 16 doesn't go into 40, so our largest common factor is 8. So that's our GCF. Now, when we factor it out, it's like we're dividing everything. So it's like I'm putting an 8 under each of these terms. 16x divided by 8 would be 2x. 40y divided by 8, again 40 divided by 8 would be positive 5, nothing to do with the y. That would be factored form. Once if I have my factored answer and I want to check it, I multiply it out, and if I multiply this and get back to my original problem, then I am correct. All right, going through the next one, we have 6x squared plus 30x to the third. So again, the first question I ask, does the smaller coefficient, the smaller number, go into the larger one? Does 6 go into 30? Yes. The second question we need to ask, do they have a common variable? In this case, they both have x. What is the largest value of x I can take out of both of them? It's going to be the same as what is the smaller exponent. So in this case, squared. So I can take 2 x's away from both of these two terms. So again, it's like I'm dividing by 6x squared. And you do not need to write this division part out, but that's essentially what's going on. You're really asking yourself, what do I multiply 6x squared by to get 6x squared? Or you can think of it as division, either way. But either way, you should get 1. 6 divided by 6 is 1, x squared over x squared, they cancel. 30 divided by 6 is 5, x to the third over x to the second, again quotient property, x to the first. How do I know this is my greatest common factor? Does what's inside parentheses factor any further? The answer is no, so 1 plus 5x, there's nothing in common I can take out. That means I am done. So again, I would like you to go through and ask yourself the 2 questions. First question, does the smaller number go into the larger one? The smaller number doesn't always have to be first. So like this first example, or this next problem, 4m minus 2. 2 is the smaller number. Does 2 go into 4? Yes. So that means 2 is my GCF of the numbers. And then question 2, do they have a common variable? I would like you to pause the video and try each of these on your own. All right, so on the first one, again, we said 2 goes into 4, so 2 is my common. They do not have a common variable, so 2 is my GCF. Oh, sorry, this should be 2m minus 1. And then when I go, does 2 go into 4? Yes. They have a common variable in this case. And again, if you need to write the exponent of 1, so 2w to the 1 is my smaller exponent. So then I'm dividing 2w out of each term, so I'm left with 1w plus 2. Third term, 3q is my GCF, and I'm left with 5q minus 1. And the last one, all I can take out is 2, so I'm left with a plus 5b. So the next part we're going to do is we're going to put the 2 parts together. We're going to put the factoring part with the solving part. So to solve an equation by factoring, what you need to do is you need to factor, set equal to 0, and solve. So the factoring part is what we just did on the previous slide. So again, I have 2x squared plus 8x equals 0. The first thing I need to do is factor. So I look, does 2 go into 8? Yes. Do they have a common variable, x? What's the most I can take out? Well, the smaller exponent is 1. So it's just 2x. I'm going to divide 2x out. 2x squared divided by 2x is 1x. If you want to write the 1, you can. You don't have to. 8x divided by 2x, well, 8 divided by 2 is 4. X over x will cancel. So that's the first part, the factoring. Part 2, equal to 0. Now we can use the zero product property. Again, we can split the problem. On the left here, we're going to divide by 2 and we get 0 equals x. On the right side, we're going to subtract 4 and get x equals negative 4. And so the last thing we need to do, write our answer, smallest to largest. So this section or slide of this section is literally just putting the two parts together. So I'd like you to pause the video and try these two on your own. All right, so on the first one, or the A problem here, we factored out A as our GCF. You could put 1A if you wanted. Again, when I have A equals 0 here, there's no solving, so I can just leave it and get 7, so A equals 0 and 7. GCF of the P problem is 3P. I'm left with P minus 1. Set each part equal to 0. Do you have to draw that vertical bar splitting the problem into two parts? No, you don't. Some find it useful, some do not. Either way, you're doing the same thing. So you get P equals 0 and P equals 1. All right. Now, how you're most likely to see this is something like this. But this is going to come up a lot in this chapter as well. In order to solve any quadratic equation, it must be equal to 0. It's always got to be equal to 0 before you can solve. So you can't use the zero product property unless it equals 0. So whatever is happening here, so this equals to 15n, we are always going to move the value so that the n, the squared term, in this case the 6n squared term, is positive. So we look, is it positive where it is? Yes. That means we're going to move everything to the left. So we're going to subtract 15n from both sides. That cancels it out from the right, and we have 6n squared minus 15n equals 0. It is now just like the previous problems. Factor out the GCF. Does 6 go into 15? No. All right, what is the largest number that does go into 6 and 15? Well, that is 3. Do they have a common variable? And what's the largest exponent I can take out? That would be 1. So my GCF is 3n, so I'm going to factor out 3n. Now I'm going to use the zero product property. Solve, divide by 3, I get 0 equals n. Over here I get 2n equals 5. Divide by 2 and I get n equals 5 halves. So my final answer, n equals 0, comma 5 halves. Same concept here on the one on the right. Pause the video and try this one on your own. So again, you subtracted the 24b. Your GCF was 3b, so we factored that out to have 3b times 3b minus 8. Solve. And again, leave like 8/3 as an improper fraction. It is easier to see where 8/3 is coming from than to write 2.67. All right. Our last part of this section is going to be dealing with the vertical motion model. We're going to talk about a few different types of word problems, but this is going to be the one we use the most, and we will come back to it a couple different times in this chapter, as well as future chapters as well. So, to go through what each of these is. H, this is the height. Whenever we're talking about finding the height of an object or something like that, or what is the height of the object after so much time, or when does the object hit the ground or whatever, h is the height. It acts like our y value. And again, all of these are going to be in feet. Negative 16t squared is always going to be negative 16t squared. That is gravity in terms of feet. So negative 16t squared, that is gravity always pulling you down. V stands for velocity, and more specifically, the initial velocity. And that will be in feet per second. This is how fast are you throwing an object in the air, or it's like, say, a rocket being shot off. How fast does it start? S represents the starting height. Also in feet. Obviously, if you're on the ground, the starting height would be 0. If you're, say you're standing on the roof of a building, well, then you need to know how high you are standing before you can calculate all of this stuff with the formula. If you were to look this up online, you will also see it written as h sub 0, the height at time 0. But we are going to stick with S for starting height. T equals time, and you guessed it, seconds. So T is time, and that would be both there and there. So time appears twice in this formula. And that's kind of what makes it a quadratic one. So when we are calculating this, so it says a dolphin jumps out of the water with an initial vertical velocity of 32 feet per second. Well, V will always be given in the problem in some form. It will say initial velocity of, boom, here, 32 feet per second. If it's jumping out of the water, that means that our starting height, which we call S, is going to be 0. So when it asks us to write a model for the dolphin's height, well, the height is going to be, and again, we've got gravity always pulling us down, plus our initial vertical velocity of 32 times t, and our starting height was plus 0. Now when we go to do this, since it's plus 0, it's not really there. So it's really going to be just this. H equals negative 16t squared plus 32t. When the dolphin hits the water, so basically the dolphin jumps out of the water, lands in the water. When it lands in the water, the height again is 0 because we're saying the water would be the equivalent of the ground. So that means we're going to go 0 equals negative 16t squared plus 32t. And we don't need that plus 0 at the end. And now we need to solve this. Well, this is just like what we've been doing. Does 16 go into 32? Yes. Now, one thing that we haven't talked about yet, if the leading term is negative, so this leading coefficient is negative, you always have to factor that negative out with your GCF. Your GCF always has the same sign as the leading term. All right, so now we're going to factor out negative 16t, so I'm left with t minus 2. Be careful of signs here because we're taking positive 32t divided by negative 16t. Again, set equal to 0. So here we're going to divide by negative 16. We get 0 equals t, and here we get t equals 2. We get two answers, but we're trying to figure out, we go back to the question, after how many seconds does the dolphin hit the water? It can't be two answers. So if we think about it, the dolphin, here's the water, the dolphin jumps and then lands in the water. Well, this is going to be at time 0. That's not our answer. That's when the dolphin leaves. So here where t equals 2, that means this is our answer. So our answer is going to be 2 seconds. So that 0 is what we would call an extraneous solution. It doesn't work in the context of the problem. Here we're talking, instead of about a dolphin, we're talking about water from a fountain. I would like you to pause the video and try and write the model and solve it on your own. All right, so again, gravity plus our velocity, which is 20 feet per second. So h equals negative 16t squared plus 20t. Set it equal to 0 and solve it. GCF negative 4t. 16 does not go into 20, so does 2? Yes. Does 4? Yes. Does 8? No. So we 4. So leading coefficient is negative, so our GCF is negative. So we factor out negative 4t. Again, we get 0. That would be the time the water leaves the fountain, not the question we're answering. How long will it take for a drop of water to hit the ground? And we get 5/4. And again, when we have a word problem, that is when you would convert it to a decimal, so you get 1.25 seconds. If you have any questions, make sure you ask them in class. This is important that you understand the word problem, how you set up vertical motion, as well as how you use the zero product property. If you don't have any questions, you're good to go. We'll see you in class. Have a great day, everyone.